Hi, this is the run through of the Component 3 Requirements for Life mock. This is the second mock, so this is the one that you all did on the Wednesday in 2017. It could be a different day on the 2018, but there we go. So this is the A2 mock, so if you recognise this question then potentially you're in the right area. It's exam time, so I have a ruler, I have a calculator, I've got a pencil, I've got a black pen because I'll need a black pen because these papers are scanned in, and I've got a highlighter, but I'm going to have to remember not to use it on my answers and only to use it for working out the questions. So, question 1. This looks like a gas exchange. I can see some fish gills over here and I've got the word lung. So that's good, that's what my topic is. So they're going to be asking me what I know about gas exchange. So I've got a section, so I've got two pictures here. One's a healthy lung and a section drawn to the same scale. So the sizes should be right for the diseased lungs. So these are absolutely equivalent pictures. So name the structures A and B. So I'm looking at this diagram, and these capillaries, so these little dots I'm assuming are going to be red blood cells, and they surround the alveoli, so I'm thinking that that's an alveoli. And B, I'm thinking this is connected to all these capillaries here, so I'm thinking that that will either be an artery or this is blood, isn't it? So, but this doesn't look like blood, this isn't filled with grey, so I'm thinking this must be a bigger airway. So let me think, it goes trachea to bronchi to bronchioles to alveolus. So if it's leading into these alveoli, then it's going to be a bronchiole. Okay, so I'm just going to read through the whole question. Give two features that all gas exchange. So I've got the naming structures, that's nice and easy, that's just a bit of terminology. Name structures, two features, so, and it's all gas exchange surfaces have in common. So I'll probably need to think about that because I've done gas exchange in quite a lot of different organisms. Okay, so I've got an explain. So I'm just going to write in pencil above that. That means give a reason. But the effects that the disease, I'm going to be looking at the diseased lung picture, will have on gas exchange. Okay, might need to think about that and look at perhaps the differences. And then we're on bony fish, gill filaments of a bony fish. What do I know about bony fish? I'm already thinking that the flow is going in opposite directions, and all they've given me is the flow of water, and they've got gill plates and capillaries. So I've got to draw an arrow on a capillary to show the direction of blood flow, and I've got to use the letter H where there's high concentration or high oxygen in the gill plate, and L the lowest concentration of oxygen in the water. Okay, name this type of flow, that'll be nice and easy to do, and explain how it improves efficiency. So explain, I need to give a reason. Okay, so let's make a start then. So we'll start with the lungs. Name structures labelled A and B, so I think that A represent the alveoli, and B I've decided is a bronchiole. Right, now I need to think about this because I'm already thinking moist because it's the one everybody remembers, and permeable, and short diffusion path, and then there's the sort of capillary thing, but it says all, so that might include plants or amoeba, insects, fish, mammals. Okay, so earthworm, they're the ones that we've looked at, and some of these don't actually have blood, do they? So I'm not going to talk about blood. Instead, I'm going to talk about large surface area. So I'm going to put large surface area, and a short diffusion path, now I need to be careful here because in an exam, if you give them a big long list and one of them's wrong, you're going to lose a mark, and it is only worth 1 mark. So I'm just going to stick to the 2, and I'm really confident about those. Now, other possible answers are that they're permeable. So for example, if they asked you for 4, and that they're moist, but we can't say anything about blood because of the plant amoeba insect thing going on, where they don't have insects have that open circulation system, don't they? So they don't have a good blood supply. So explain the effects of the disease. So I now need to look back at my pictures, and I'm thinking that this is probably my alveoli, and they seem to be a bit bigger. So what does difference to size make? It means that they've got less surface area. So if I look at this has got a huge surface area around here, but this one's sort of circular and not so. And also it seems to be that this is wider here, so longer path for diffusion. And what we'll have on gas exchange, I need to be thinking about the oxygen to blood. So what will those 2 things do? Okay, so explain. The diseased lung has a smaller surface area. We've only got 3 holes instead of lots of them. Not as many edges. Smaller surface area and a longer diffusion path. So this is my reason, the effect it will have. I'm explaining the effect. So less oxygen can be absorbed, as the rate of diffusion is slower. And I think that will kind of cover it. I need to be certain of getting those 2 marks. So I've said what effect it has on, and then what the impact is in terms of oxygen absorption. Okay, on to fish. I love fish. countercurrent flow, I've spent ages learning that, brilliant. So, draw an arrow on a capillary to show the direction of blood flow in the gill plate. So if the water's going that way, the blood's got to be going the opposite way. So, there's my arrow. I'm going to do it on all three, because I'm so confident about this. And I'm going to also label it, so I'll need my ruler, because it would be stupid to not rule my labelling line. So that's blood flow. Okay, excellent. So use the letter H, indicate on the diagram highest concentration in the blood. Blood. So it's coming in with low oxygen and it's leaving with high. So be high over here. And I'll just do a little labelling line. So that I know the examiner will spot it. And use the letter L, lowest oxygen concentration, so water's coming in with high oxygen and it leaves with low. I will be able to see that, that's super. In the water part. Oh, in the water, lowest concentration, yeah. They're passing over the gill plate. Maybe I'll put the L on this side of the gill plate. Okay. Name this type of flow. So this is countercurrent flow. Countercurrent flow and how it improves. Explain. So a concentration gradient is maintained. Now I need to remember not to stop there, because the key thing is that it's over the whole gill. So over the whole gill plate. So, because I'm explaining, so gas exchange happens for longer. So I think that kind of wraps it up, and I've got my key things in. Concentration gradient maintained over the whole gill plate. I remember that being stressed to me. Just check my answers. I'm thinking, the gill plate. I might just L and H there, so that they really do know that I know what I'm talking about. Okay, brilliant. Onwards and upwards.